Hello and welcome to our next lesson in the series of these online lessons. So up until this point in my lessons we've been looking at sound, we've looked at the types of waves, we've said that there's transverse and longitudinal waves, we've then looked at how vibrating objects can create sounds, we've looked at amplitude and pitch, and we've looked at how your ear detects sound. We now need to start looking at light. So today's lesson is entitled Light. So if in your exercise books or on a piece of paper you could write the title Light. By the end of this lesson you should be able to describe how light travels, you should be able to explain how we see objects using light, and you should be able to evaluate how the speed of light can be used to calculate distancing. This is a very difficult learning objective, this bottom one. These are the first two I want us to focus on. If you can do that last one, fantastic. So as always, if I can just move that out of the way, as always we're going to use the dark chalkboard and we're going to start by writing two really important points. We can start by saying that light is a transverse wave, is a transverse wave. Now if you think back to the very first lesson we did on this, or the very first lesson we did on waves when we started sound, we said that a transverse wave is a wave that moves at right angles to the direction of the wave. So essentially what that means in plain English is that it goes up and down. So if our wave is travelling in this direction from left to right, I don't know what's happened to that arrow, but it's the best I can do. The wave is travelling from left to right, but it's also going up and down. So it's travelling at right angles to the direction of the wave. The other thing that we need to say, and this is really important, people always get this wrong when they start trying to draw ray diagrams in particular, is that light travels in straight lines. It never bends. The only time it bends is through something known as refraction. However, unless it's going through refraction, it travels in straight lines. So we can say, and I'm going to put it in red again because it's important, we can say that light travels in straight lines. Hope if I can spell straight. In straight lines. Okay, so light is a transverse wave and it always travels in straight lines. Now, there are some key words that we're going to need to talk about, and a good way of doing that would be to use this image that I've put on the PowerPoint. I'm just going to paste it onto the chalkboard so that we can label things. This is just taken from your Caboodle book. Make it a bit bigger so that we can label it a bit easier. What this shows, I know it's not scanned in the best, but I'll just show you. We've got someone trying to read a book, so this is a book, and then we've got a lamp which has got a light bulb in producing light. So the first thing we need to define is the word source. 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 Now, a source can be defined as something that emits light. Okay? Something that emits light. So, we can say an object that emits, E-M-I-T-S, emits light. And we can add underneath there as an example, we can say e.g. a light bulb. So on our diagram here, we've got our source, which is the lamp. So this is our source. Okay, and it's producing light, it's emitting light. Just for your reference, The word emit means to release or to generate, okay? So we can just add underneath here, emit means to release or generate. So this source is releasing or generating light, and in this case our source would be the lamp and the bulb. Okay. Now, what's happening here is that the light is being emitted by the source. It is reflecting off the book into the person's eye, which is absorbing the light. So we can say that light is emitted. I'm not sure how you spell emitted, if I'm honest. Emitted from the source, and then reflects, and I'm going to use that as an important point, reflects off the book and is absorbed by the eye. By the eye. So the light, notice it's travelling at straight lines, it's travelling in straight lines, reflects off the book, bounces off of the book. We'll do a whole lesson on reflection after this one. It reflects off the book into the person's eye, and they then make sense of it. Now, the book is said to be transmitting light. What that means is it's not producing the light itself, but light is being bounced off it, or it's passing through it. So we can say that transmit means when light passes through or off an object. Okay? So if an object is having light pass through it, such as a pane of glass, or if light is bouncing off an object, we say that it transmits the light. Now, this is because some objects are said to be luminous and some are said to be non-luminous. Examples of this, so this lamp in this diagram is luminous, whereas the book is non-luminous. And these are our next two keywords before I have to wipe the board. So the word luminous L-U-M-I-N-O-U-S, is an object that creates light. Okay, or it's an object that gives out light. An object that gives out light. So a luminous object is an object that gives out light. And again, we can put underneath here that would be, e.g., the light bulb. It could also be, for example, the sun. A non-luminous object are objects that do not give out light. Okay? So non-luminous is an object that does not give out light. Give out light. On our diagram at the top, this would be the book. The book doesn't give out light, but the light simply reflects off the book. So we can add underneath here, and I'm going to put it in red because it's important, that light reflects from these so we can see them. From these so we can see them. Okay? So we've said that light is a transverse wave. It travels in straight lines. It doesn't bend. It only travels in a straight line. We've said that a source is an object that emits light. If it emits, it releases or generates light. This is such as a light bulb, such as here. This is the source. We've said that light is emitted from a source and it then reflects off the book or off an object and is absorbed by the eye. So we've said that the light is generated by the light bulb, it's released or transmitted from the book, reflected from the book, transmitted into the person's eye. We've said that the lamp is a luminous object because it gives out light, and we've said that the book is a non-luminous object because it doesn't give out light. It simply reflects from it. So if we have a look back at our learning objectives, remember you can pause this video at any time to make sure you've got all the notes. We said that by the end of the lesson we need to say how light travels. You should be able to tell me now that light is a transverse wave that travels in straight lines, and you should be able to tell me how we see objects. Essentially, a source will create light, which is then transmitted from non-luminous objects into our eye so that we can see. Before we move on to the final part, I just want to quickly define two things. And I'm going to make this whole screen because that's what we normally do. So I want to just define two things. Okay? The first word that I want to define is the word transparent. Transparent. Okay? If something is transparent, it means that light can travel through it easily. It means that very little light is absorbed. So we can say an object that light can pass through easily without much of the light being absorbed. Being absorbed. An example of this would be a pane of glass. So, e.g., a glass window. Now, when light passes through a glass window, or when it is transmitted through a glass window, very little of the light is absorbed. So this results in a very clear image. So if light passes through a transparent object, it makes a clear image of an object. So if you look at somebody through a transparent pane of glass, you can see them very clearly. This is different to what's known as a translucent object. Translucent object. Now, this is where light can travel through them, but the light is scattered. So an object where light can pass through but is scattered so that an object is not clear. So this would be looking through, example, frosted glass. If you try to look through frosted glass, you can perhaps see an outline of someone, you can see a silhouette or a shadow, but you can't see them very clearly. So we can put underneath here, e.g., frosted glass, and we can say that the object is not clear. So I'm going to write over there so that I've got room. We can say objects will not be clear. The final one we need to define is what's known as opaque. Opaque. Now, opaque is spelled O-P-A-Q-U-E. O-P-A-Q-U-E. Okay? Now, an opaque object is a material that does not transmit light. So, a material that does not transmit light. Okay? What that means is that all of the light is absorbed by the object. So all light is absorbed by the object. I'll just clean that up because that's a bit absorbed by the object. As a rule of thumb, transparent objects are ones that you can see through clearly. Translucent objects are ones that you can kind of see through, but you can't see clearly what's behind the object. And opaque is something you cannot see through. Okay? An example of an opaque object would be wood. So, e.g., wood. You can't see through wood, therefore it is opaque. So transparent is one that you can see objects through clearly, such as a pane of glass. Translucent is an object that you can kind of see through, but it's not very clear. Whereas opaque is a material that you can't see through whatsoever. Okay? So let's have a look at this final learning objective. Now, as I said at the start of the lesson, this is a very difficult concept, so it doesn't matter if you can't understand this. Just try your best, and if you do understand it, great. So, the first thing we need to write down is that light can travel through all mediums. It can travel through liquids, it can travel through gases, it can travel through some solids, it can even travel through a vacuum, okay? So we can say that light can travel through all mediums and vacuums. Remember, a vacuum is an area with no particles, which we discussed in previous lessons. Okay? So just to refresh your memory, I am going to add underneath there that a vacuum is an area with no particles, and a medium, we'll change our colour to one that sort of stands out, we'll go orange. A medium is such as a solid, liquid or gas. So solid, liquid or gas. Okay? Now, it takes about 8 minutes for light to reach the Earth from the Sun. And I've got a diagram for us to use here for that. It's on the PowerPoint. It's taken out of Caboodle. So if we can just paste that in. It takes about 8 minutes for light to reach the Earth from the Sun. Okay? From the Earth to the Sun, it's about 150 million kilometers. Okay? Now, the speed of light is about 300,000 kilometers per second, or 300 million meters per second. So we can say, or we can write somewhere, in fact, we'll go this colour, we can say light travels at ... So it travels at ... 300 million meters per second, or we can convert that into kilometers and say 300,000 kilometers per second. Okay? We can use what's known as light time to measure a distance in space. So light time is a measure of distance in space. Okay? Now, for example, a light minute is how far light travels in 1 minute. So we can say a light minute is how far light travels in 1 minute. And to work that out, we could do 150 million kilometers, which is written here. So 150 million. So 150 million kilometers divided by how many minutes it took, which is down here. So down here we say 8.3 light minutes. Therefore, we know, ignore the divide bit, we know that Earth is 8.3 light minutes from the Sun, because the light has travelled 150 million kilometres in those 8.3 minutes. Okay? That's a very difficult concept. That's very, very difficult. If you don't understand that, it's not the end of the world. However, just try your best with it. So just to clarify, it's travelled 8.3 light minutes, which is 150 million kilometres. If we wanted to work out what 1 light minute is, we could do 150 million divided by 8.3, which would give us like 18 million roughly. Therefore, 1 light minute would be 18 million kilometres. Right then, what I would like you to do, as always, I would like you, please, to have a go at the questions that are on the PowerPoint at the moment. I would like you, please, to pause the video at this point. In your books, I would like you to write out the sentences, leaving in the correct word, and then for question 2 and 3, you need to write out the question before answering it in your book. You are going to need a different coloured pen, preferably green. However, if you haven't got a green pen, it doesn't matter, just get a different coloured pen and press play once you've had a go at all 3 questions, and we can mark them. So pause the video now and then grab a different coloured pen to mark them in a moment. Okay then, so you should have spent some time having a go at these questions. Let's get them marked so that you've got some answers in your book. So the first question looked like this. What we need to do is we need to leave out the incorrect word, leaving the correct one in. So I'm going to change my pen to red and I'm going to cross out the ones that you should have had. So the first one should have says, the sun is luminous. Luminous. Because it emits light. Remember, the sun generates light. It doesn't reflect it. It generates it. Therefore, it emits light. The light reflects off an object that is non-luminous into your eyes so that you can see it. Most objects that do not transmit light, they are opaque. They are opaque. So the first question should have read, the sun is luminous because it emits light. The light reflects off an object that is non-luminous into your eye so that you can see it. Most objects do not transmit light. They are opaque. Let's have a look at this next 2 then. Okay? Let's have a look at these next 2 that you should have done. So if we can paste it in and move it up here, I'll make it a bit smaller so we can still read it, but I can answer them below. So the second question says, explain why it is so dark at the bottom of the ocean even though water is transparent. So you should have said that light is absorbed. So for number 2, you should have said light is absorbed by water for 1 mark. So light is absorbed by water for 1 mark. And your second mark would come from, so that by the time you get to the bottom of the ocean, all of the light has been absorbed. So at the bottom of the ocean, all light has been absorbed from the surface. So your 2 marks come from saying that light is absorbed by water, and therefore by the time you get to the bottom of the ocean, all the light has been absorbed from the surface. 2 marks. Our final question, question 3, says, describe the journey that light takes from the sun to your eye when you are looking at a fish in a pond. So you should have said, first of all, that the sun emits light. So sun emits light. You could have then said that the light travels through space to Earth. So light travels through space to Earth. You could have then said for your 3rd mark that the light travels through the air. Light travels through the air and moves into the water. So we can say that light travels through the air into the water. For your 4th mark, you could have then said that the light reflects off the fish. Light reflects off the fish and then moves out of the water into your eye. So the light moves out of the water. Light moves out of the water. And then finally, we can say that the eye absorbs the reflected light. So just to explain those marks, I'm going to draw a quick diagram. So we've got you standing by a pond. We've got a fish in the water. So we've got a fish in the water that looks like this. And we've got the sun in the sky. Your marks come from saying, first of all, when it's all written here in red, your marks come from saying that light is emitted by the sun and it travels through space into the air onto the fish. Light then is reflected off the fish into the eye of you, who then sees the fish. Okay? Whenever we draw diagrams like this, and you'll notice on the diagrams that I've used earlier, we draw arrows on the light rays to show which way they're going. So light, the sun emits light, the light travels through space to Earth, the light travels through the air into the water, it's reflected off the fish, the light moves out of the water into the air, and the eye absorbs this reflected light. So 6 marks for those. So, that concludes our first lesson on light. You should now be able to tell me how light travels. It travels as a transverse wave in straight lines. You should be able to explain how we see objects using light. So there's always a light source which emits light, which then bounce off non-luminous objects into our eye where our body absorbs it. And you should be able to tell me how to use light minutes or light years to calculate distance. So 150 million kilometers is equal to 8.3 light minutes. That concludes our first lesson on light. If you have any questions, please do not hesitate to contact me and let me know if there is anything you need. I will see you next time. Thank you very much.